In this Try This problem, we're going to use the first derivative test to find local mins and maxes of the given functions, if they exist. All right, so let's try to apply the first derivative test to find the local mins and local maxes of the given functions. So let's look at number 1 first off, and we're going to need to take the derivative to find the critical points, right? So we get 3x squared minus 4x plus 1. And setting that equal to 0, we get 3x, and then x here, and minus 1 and minus 1. That's factored correctly. So then if we have the product of two things equaling 0, we set each of them equal to 0. So 3x minus 1 equals 0, and x equals minus 1 equals 0. So here we get x equals 1/3, and here we get x equals 1. So I'm going to put those on a number line. Here's 1/3, and here's 1. And remember, we want to check the slopes on all the different intervals. So from negative infinity to 1/3, we want to check the slope. And then from 1/3 to 1, check the slope. And then from 1 on, we want to check the slope to find out when it's increasing and decreasing. So to check the slope, I'm going to pick a number on the left side of 1/3, and I'm going to go ahead and try 0. So I'm going to find f prime of 0. And if I find f prime of 0, that's 3 times 0 squared minus 4 times 0 plus 1. And that's going to give me a positive value. We really don't care what value it is. We just want to know if it's positive or negative. So it's positive. So that means on this interval, it's increasing, doesn't it? And then between 1/3 and 1, let's take 1/2. So if I find f prime of 1/2, I get 3 times 1/2 squared minus 4 times 1/2 plus 1. And again, we're just trying to find out if it's a positive or a negative value. So we get 3 times 1/4 minus 4 times 1/2 plus 1. And that's going to give us 3/4 plus 1 is 1 3/4. So 3/4 plus 1, and then we're going to subtract 4 times 1/2 is 2. So that's going to be a negative value, isn't it? So it's decreasing. Now, do you see it's increasing until 1/3, and then it's 0 at 1/3, and then it's decreasing on the right of 1/3. So this is a max. All right. And then let's pick another number on the right side of 1. So let's do 2. If we did f of 2, we would get 3 times 2 squared minus 4 times 2 plus 1. And that's going to give us 3 times 4 is 12. Minus 8 plus 1 is going to give us a positive number. So on the right side of 1, it starts to increase again. So what does that tell us happens at 1? It means there is a local min at 1. So the way we give our answers for these, and the way I'm going to expect you to give your answers, is you're going to be able to identify that the maximum occurs at x equals 1/3, but you're going to actually need the maximum value. So to find that, you're going to take f of 1/3, okay? And so you plug 1/3 into your original function, and you get 1/3 cubed minus 2 times 1/3 squared plus 1/3. And that is going to give you your max. When I calculate it, I get 0.148. So the way you write your answer is that there is a local max of 0.148 at x equals 1/3. And likewise, we can plug 1 into the function to find the local min. All right, and so that equals 1 plus 1 is 2, minus 2 is 0. Okay, for problems number 2 and 3, let's skip to the next slide. All right, so let's look at these other two problems on this page. I'm going to look at problem number 2 right here. So I have f of x is equal to x squared times x minus 4. I'm going to take the derivative, and I get x squared times 1 plus x minus 4 times 2x. And multiply that out, I get x squared plus 2x squared minus 8x. So that is 3x squared minus 8x. And then I set that equal to 0 in order to find the critical points. I can factor out an x, and I get 3x minus 8. And so that means either x equals 0 or 3x minus 8 equals 0. So that means x equals 0 is one critical point, and 3x minus 8 equals 0 means 3x equals 8, and x equals 8/3. All right, so I put those on a number line, 0 and 8/3, and then I try numbers on all sides of those in the first derivative. So, and this is again the first derivative. So let's take a number on the left side of 0. So let's try -1. F prime of -1. Then you get 3 times -1 squared minus 8 times -1. And that is going to be 3 plus 8, which is positive, right? So we get positive here. That means it's increasing over here. Then between 0 and 8/3, let's try 1. And you can pick any value you want, so I try to pick the easiest values. If I plug 1 in there, I get 3 times 1 squared minus 8 times positive 1, which equals 3 minus 8, which is a negative value, isn't it? So it's negative here, so it's decreasing. So what do we have at 0? We have a max, right? Now let's try on the right side of 8/3. Let's try 3. And if I plug 3 in, I get 3 times 3 squared minus 8 times 3. And that gives me 3 times 9 is 27, and subtract 24, and that's a positive number, isn't it? So we see it's increasing again. So it's decreasing until 8/3, then it's increasing, which means we have a minimum at 8/3. And the final problem is f of x equals x to the 5th minus 5x to the 4th. When I take the derivative of that, I get 5x to the 4th minus 20x cubed. And I can set that equal to 0 to find the critical points. Okay, and I'm going to factor out a 5x cubed. So what I have remaining is an x there, and then minus 4. Pretty easy to factor that one. And so now that means that either x cubed has to equal 0 or x minus 4 equals 0. In this case, x equals 0 and x equals 4. Those are my two critical points. I put those on a number line, 0 and 4. And finally, I test numbers on either sides of all sides of those into my first derivative. And I can use this form of it right here. So if I plug a -1 in, if I plug -1, f prime of -1, I'm going to get 5 times -1 cubed times -1 minus 4. And that's going to give me what? That's going to give me -5 times -5, which is going to be a positive number, isn't it? So, all right. You could actually plug it in anywhere. You could plug it in up here as long as you're plugging it in the first derivative, all right? And then f prime of between 0 and 4, let's take 1. If I took f prime of 1, and I'm going to go ahead and plug it in here so that you can see what I do. So 5 times 1 to the 4th minus 20 times 1 cubed. And you can see that that's going to give me a negative value, isn't it? And it doesn't matter that it's -15. You're just trying to find out if it's positive or negative, and it's negative, right? So this was positive, this is negative. So we have a max here at 0. And then one more value on the right side of 4, let's take 5. And so if I plug 5 in here, I get 5 times 5 to the 4th minus 20 times 5 to the third, and that gives me 3,125 minus 2,500. All right, and so that's going to be a positive value as well. So it's increasing again on this side of 4. And so if it's decreasing on the left side of 4 and increasing on the right side of 4, you can see that we have a min, a local minimum at 4. All right, so there's one thing that I forgot. Once we identify the max, let's go ahead and find out what the max is. There's a max at x equals 0, and to find out what that is, let's plug 0 in here. So if we take f of 0, we get 0 squared times 0 minus 4, which is just 0. So there's a max, a local max of 0 at x equals 0. And then we know that there's a local min at x equals 8/3, but to find out what that is, let's find f of 8/3. 8/3 minus 4, and that gives us negative 9.481. All right, so we know there's a local min of negative 9.481, and that occurs at x equals 8/3. All right, we have to do similar over here. So we know that there's a max at 0. So if we plug 0 in, if we take f of 0, we get 0. So here we know we have a max. We have a max of 0 at x equals 0. And then we know we have a min at 4, so to find that, we take f of 4, and we get negative 256. All right, so we have a min of negative 256 at x equals 4. All right, so the key is I wanted you to be aware of how you should write your answers. You're going to actually have to find what the maximum and the minimum values are, and not just where they occur.